every time you watch a movie or book a flight, or even just scroll through your feed, there are these invisible decisions being made about your life every single second. Today, we're going to pull back the curtain on the powerful field that pretty much runs our world, data science. To really get a feel for the scale we're talking about, let's just start with this one number, 2.5 quintillion. I mean, that is a number so ridiculously big, it has 18 zeros after it. And here's the really wild part. That incredible amount of information isn't created over a year or even a month. It's created every single day. It's coming from all the photos we post, the shows we stream, our smartwatches, even our refrigerators. We are absolutely swimming in an ocean of information. Now, this massive flood of data isn't just some cool trivia fact. It's a huge, fundamental challenge. What do we even do with it all? And that brings us right to our first section, the data deluge. Think about it. With this digital tsunami washing over us constantly, the most important question is actually a pretty simple one. How in the world do we make sense of it? How do we find the few valuable signals that are hidden in all of that noise? Well, the answer to that question is a field that has quietly become maybe one of the most important of the 21st century. This is where data science steps in. It's a whole discipline built to do exactly that, to find meaning in the chaos. So what is it really? The best way to think about it is like digital detective work. Data scientists are the detectives who sift through these mountains of raw information, looking for clues, these hidden patterns and insights that you never spot at first glance. Let me give you a classic and kind of weird real-world example. So Walmart's data scientists discovered that right before a hurricane is about to hit, sales of strawberry Pop-Tarts just skyrocket by 7 times. Now, that seems completely random, doesn't it? But here's the key. From a data science perspective, the why isn't always the most important part. Just discovering the pattern itself, that's the goal. In that Pop-Tart story, that is data science in a nutshell. It found a valuable, totally non-obvious connection. And for Walmart, the decision that comes out of it is super simple, but really powerful. A hurricane's on the way? You better believe we're going to stock the shelves with strawberry Pop-Tarts. That's a smarter business decision, and it's powered entirely by data. So how did data scientists actually do this stuff? Is it really magic? Well, not quite. To understand it, we need to peek inside the data scientist toolkit. Okay, so the absolute foundation of everything is statistics. You can think of it like this. If data is a new language that we're all speaking, then statistics is the grammar. It gives us the rules to describe what's going on, analyze it, and then make solid conclusions we can actually trust. For instance, a core idea is the difference between a population and a sample. Look, you can't survey every single person in an entire country. That's the population. It's just impossible. So what do you do instead? You analyze a smaller representative group. That's your sample. And here is where the statistical magic really kicks in. As long as your sample is big enough, its average is going to be almost exactly the same as the entire population's average. This is a huge deal. It's the principle that lets data scientists make incredibly confident predictions about millions of people just by looking at a few thousand. So, if statistics is the grammar, then machine learning is the super-powered engine that can read billions of books in a matter of seconds. It's what automates the whole hunt for patterns, letting us dig through data sets that are just way too massive for any human brain to handle. Generally, machine learning comes in 3 main flavors. First, you've got supervised learning. That's kind of like studying with flashcards. You give the computer a bunch of examples that already have the right answers, and it learns from them. Then there's unsupervised learning. This is more like dumping a giant box of Legos on the floor and just asking the computer to sort them into interesting piles on its own. And finally, there's reinforcement learning, which is basically like teaching a dog a new trick. The algorithm learns by trial and error, getting little rewards or treats when it makes a good decision. Okay, so that's all the theory behind the curtain. But this stuff isn't just stuck in a lab somewhere. Let's talk about where this data science magic shows up in the real world. In tools you probably use every single day, maybe without even thinking about it. You ever finish a show and wonder how Netflix just knows exactly what you want to watch next? That is not a lucky guess. Its recommendation engine is analyzing everything you've ever watched, and it's comparing your tastes to millions of other users, all to make a seriously accurate prediction about what you'll love. Or how about when you upload a photo and your phone instantly suggests who to tag? That's supervised learning right there. The algorithm has been trained on thousands of photos you've already tagged, so it's learned the unique patterns of all your friends' faces. It's pretty incredible. And that spam filter that keeps your inbox actually usable? Yep, that's another machine learning model at work. It has learned over time to tell the difference between a real email from your friend and all that junk, saving you from a daily avalanche of scams and ads. So here's the main thing to take away from all this. Data science isn't some far-off, futuristic idea from a movie. It is an invisible engine that's already running in the background of your life, working 24/7 to make your digital world feel more seamless, more personal, and, well, just plain better. And really, the applications go so far beyond just convenience. We're talking about predicting diseases before they even start, creating smarter energy grids to fight climate change, designing cities that work better for everyone. The potential is just about endless. Which leaves all of us with one final and really important question. Now that we have all this data and these amazing tools, what impossible problem are we going to solve next?